So we start with the number system. Number system. The first set of number, we call it set of natural number, and we denote set of natural numbers, and we denote it by n, and the elements of n are 1, 2, 3, 4, 5, so on. So one thing, this is the first set. Why do we call this set of natural number? Actually, this natural word come from the Latin verb nascere, nasi, and natusum. Nascere mean I born. This mean I have born, and this mean the passive I have been born. So the root word in this verb part is not. So not is the root. In Sanskrit, like we call dhatu. So this is not for many words like national. National is based on the dhatu, the root word not. This means where you born. Native. And also the word prenatal, before birth, postnatal, after birth. So this word not means birth or born. So this, why we call the words that mean the natural number mean the born number. Why do we call the born number? Because in Roman, numbers are denoted by the fingers, like this is 1. The notation used for 1, this is for 2, this is for 3. This means 1 finger, this for 2 finger, this for 3 finger. This is 4 and this is 5. 4 actually also like this in ancient time. This was the symbol used, and this is the shape of the hand is like form V. So fingers, because they are born with the human birth, that's why they call them natural number. Natural numbers start from 1 and keep going on, so infinity. Up to infinity, it is the natural number. One thing you notice here, this set is normally used for counting. But here you see this set satisfies some property, algebraic property, some do not. Like you say, if I take any two numbers from this set and I add them, again I will find a natural number. Any two number I pick, like I say 3 plus 4, that is 7. 7 is again somewhere here. So these are natural number. But you see, if I use the subtraction, then what happens? if I subtract 2 from 1, that means 1 minus 2, I get minus 1. And this minus 1 is not element of n. That means this set need a further development. What is the set is developed in the integers, and a new set was invented or came in existence that has the elements of this type: minus 3, minus 2, 0, 1, 2, 3, and so on. This is set of integers. Why we call it set of integer? Now this is the question. This is also again this word come from where? This is also a Latin verb that we call tango, tangere, and the third form is tactus sum. So this means I touch. This verb is touch. And now integer can be break up in plus teacher. This means not, and this means touch. So this means not touched. Not touched means complete. So these numbers are complete, not the fraction. Like this, you can say they are the complete number. So that is the way we call the set of integer. Further, see this set, addition and subtraction, both binary operation are active in this set, but you see the fraction is not. That means division, if I divide, suppose 1 by 2, then this element is not in Z and not in N. So a new set was invented that we call Q. Q is the set of rational number, and the definition of a rational number, a number in the form of P by Q. Q is non-zero, because if Q becomes 0, then this whole number becomes infinity. And PQ are integers. So this is rational number. Rational also the same from the word. This is we call set of rational numbers. This is also from the root rat. This is the root word. This also make many words. Rat means thinking. Think. This is mean think. So this also make many words, like you say ratify, rational. So many other words also can be formed on this root. So this is the word which were thought. That means suppose you say that one apple is there, and if you want to divide in two parts, then one is in two parts, this become 1 by 2, 1 by 2. So this is the mathematical notation for half. That means you can say half plus half. Like you can also say that mathematics is a type of stenography. The language is symbolized in the form 1 by 2, like half 1 by 2. So half is a symbol used. So it is a type of stenography also. Thereafter, Pythagoreans. Pythagoras already found it the formula for the square rectangular, for the right angle triangle. Suppose this is the right angle triangle and this angle is right. If I take its perpendicular is unit and base also unit, then by Pythagoras formula I know hypotenuse is under root 2, because the formula is given by Pythagoras as square is equal to b square plus b square. Now they notice that this number is, the Pythagorean noticed that under root 2 is not natural number, neither integer nor rational number. So they thought that there are still numbers which are not yet be covered by these three sets, and a new set came in existence that we call irrational number. Irrational numbers. Now what is the definition? Irrational is not yet thought. Not yet thought. So which number which were not came in the thinking? Irrational number. And what is the definition? The set notation we use I, and the definition, how do we write? Non-repeating non-terminating. So this is set of irrational number. Now if I ask some example of irrational number, you can say under root 2, under root 3, pi, this kind of number. But specifically, if I ask a question, write any two, like if I make a question, write two irrational numbers between 1.1 and 1.2. Now we have to write irrational number between 1.1 and 1.2. Easily we can write the rational number. If I say, suppose first, if I make one more question, write two rational numbers between 1.1 and 1.2. Very easy. We add them and divide by 2. Like 1.1 plus 1.2 divide by 2, which give us 2.3 by 2. That means 1.15. Now see this number. This number will fall between these two numbers, and this is rational number. Similarly, if one more number, here I make the question 2, then I take this and add 1.1 plus 1.15 divided by 2 give us 2.25 divided by 2, that is 1.125. So this is another rational number which will fall here. But now our question still exists, irrational number. Irrational number, what was the definition? Non-repeating, non-terminating. So you can say 1.1 0 1 0 0 1 0 0 1 0 0 1, and this is keep going on. See, this number is 1.1, it is larger than this and smaller than this, so this number will fall between these two numbers. And another number 1.1 1 0 1 1 0 0 1 1 0 0 0 1 1, many other numbers keep going on. One more number like 1.12 0 1 0 1 1 0 0 1 1 0 0 0 1 1 0 0 0 0 1 1. So this number also lie between these two numbers. So these are the irrational number. These numbers are not terminating, they are keep going on, and they are non-repeating. Like sometimes rational number also we write somewhat like this. Say you say 1.3 bar. This is rational number. This is rational because this number is actually 1.3 bar is 1.3333 so on, and this number failed to fulfill the condition non-repeating because it is repeating 3333. So this is a rational number, not irrational number, right? So you understand the concept of number, and it is the very important part because numbers are very important to understand mathematics. Again, now finally, set of real number. Set of real numbers. Notation we use R is the union of rational and irrational number, or in large perspective you can say R is the superset containing all natural number, integer, rational number, irrational number. This is R. Physical representation of the geometrical interpretation of real number is a line where center is 0, we call origin, and right side this is 1, this is 2, this is 3 positive numbers, and left side -1, -2, -3 negative numbers. So real line is divided in 3 parts. Right to the right of 0 positive number, to the left of 0 negative number, and this is 0. So this is the physical interpretation. Here also numbers, like you can say here is 1 by 2, here is 3 by 2. So here also points 1 by 4, and same how we can say, if I make under root 2, then I draw a side of a right angle triangle. Sorry, this is, if I make this is, then this is under root 2, this is 1, and this length also 1, this is also 1. So this length we can take somewhere here. This is under root 2. So irrational number also lie on this line. This is the physically we can interpret